Welcome to the world of JavaScript date methods. In this video, we will explore how to manipulate dates and times effectively in JavaScript. We will cover essential techniques for managing time within your applications. JavaScript provides a robust set of built-in methods for handling date and time, which are essential for many applications that involve scheduling, time tracking, and data analysis. Let's begin by understanding that we can retrieve specific components of a date and time using getter methods, and modify these values using setter methods. We can also format the date into different string formats, and convert the date to Universal Time Coordinated and International Organization for standardization formats for handling different time zones. Let us learn how to create date objects in JavaScript. The first code block demonstrates how to create a date object for the current date and time using the newDate constructor without any arguments. The output displays the current date and time in ISO format. Additionally, a date object can be created from a timestamp, which represents the number of milliseconds since the Unix epoch. The second code block shows how to create a date object with a specific date and time. You can use a string representing the date and time, or by passing individual parameters for year, month, day, hours, minutes, and seconds. Remember that the month parameter is 0-based, where 0 represents January and 11 represents December. The third block focuses on using ISO date strings, which provide a standard way to represent dates and times. When only the date is given, the time defaults to midnight. Providing the Z at the end of the ISO string indicates that it is in the UTC time zone. The last block highlights how to create date objects using short date formats. JavaScript accepts common short date formats such as month-day-year, or month-day-year, and day-month-year, all of which create valid date objects. Now let us explore the getter methods for date objects. These methods are used to extract specific components of a date. The first section focuses on retrieving basic date components. The getFullYear method fetches the full year, for example 2024. The getMonth method returns the month, but note that this is a 0-based index, meaning that January is 0, February is 1, and so on till December, which is 11. The getDate method returns the day of the month ranging from 1 to 31. The getDay method returns the day of the week as a number from 0 to 6, with 0 representing Sunday, 1 representing Monday, and so on till 6 representing Saturday. The second section shows how to get time components, with getHours, getMinutes, getSeconds, and getMilliseconds methods retrieving the hours, minutes, seconds, and milliseconds respectively. These methods provide values based on your local time zone. The third section covers methods for retrieving the time in terms of values. The getTime method returns the timestamp as the number of milliseconds since the Unix epoch, which is January 1, 1970 at midnight UTC. The getTimeZoneOffset method returns the time zone offset, in minutes, between the local time and UTC. The last section demonstrates date calculations to find the beginning and end of a month. This technique uses the year and month from an existing date object to determine the first and last day of that specific month. These methods are essential for performing calculations that involve time. Let's delve into date setter methods, which are used to modify specific parts of a date object. In the first section, you see how to modify basic date components. The setFullYear method sets the year. The setMonth method sets the month, where January is represented by 0 and December by 11, and the setDate method sets the day of the month. The output shows that the date was modified to June 20, 2025. In the second section, you will see how to modify time components using the setHours, setMinutes, and setSeconds methods, which set the hours, minutes, and seconds respectively. The output indicates that the time was set to 2:45 and 30 seconds p.m. on the same date. The third section shows how setter methods can be chained to modify multiple date components sequentially. For example, setting the hours and then adding 7 days to the current date, or add 1 day using the setTime method by incrementing the timestamp. These methods modify the date in place. Finally, the fourth section explains how JavaScript handles date overflows. For example, Setting the day to 32 in January will result in February 1st. Also, if you set the month to 13, it will roll over to February of the next year. Similarly, using negative values such as -1 in the setDate function will move to the last day of the previous month. Remember to be careful with month and date overflows, but JavaScript will automatically manage it for you. Setter methods modify the existing date object, allowing you to adjust the date and time as needed. Let's now explore date-to-string methods, which are used to convert date objects into strings in various formats. The first section demonstrates the basic string conversion methods. The toString method returns a human-readable string that includes the date and time, along with the time zone. The toDateString method returns only the date part of the string, whereas the toTimeString method returns only the time part of the string, including the time zone. In the second section, you will see localized formatting options by using toLocalDateString, which returns the date in a locale-specific format. toLocalTimeString will give you the time in a locale-specific format, and toLocalString returns both the date and time in a locale-specific format. These methods support various locale formats. The third section presents the ISO and UTC formats. The toISOString method returns the date in the ISO format, which includes the full date and time, as well as the time zone. The toUTCString method returns the date as a UTC date string. These formats are optimal for data exchange and storage. Finally, the fourth section demonstrates custom formatting options by using an object to specify the formatting options like weekday, year, month, day, hour, and minute. This allows for highly customizable formatting of the date. The toLocalString method then uses the options to display the date in a customized format. These methods provide a powerful way to handle date and time strings. In this section, let's explore the UTC methods and time zone handling in JavaScript. The first section focuses on UTC getter methods. The getUTCHours, getUTCDate, getUTCMonth, and getUTCFullYear methods return the corresponding components of the date in universal time coordinated, that is, UTC time. Unlike the non-UTC getter methods, these methods ignore the local time zone. The second section presents the UTC setter methods. The methods setUTCHours, setUTCDate, setUTCMonth, and setUTCFullYear modify the date object using UTC values. These methods allow you to modify the date components while keeping the time in UTC, and the output shows the resultant date object after these modifications. The third section explains how to perform time zone conversions. The getTimeZoneOffset method returns the difference, in minutes, between the local time and UTC time. You can convert the local time to UTC by adding the offset to the time. Using the toLocalString method with the time zone option can convert a time to a specific time zone, such as America or New York as shown in the output. The final section demonstrates how to work with UTC timestamps. The date.now method gives the current UTC timestamp. You can use this timestamp to create a new date object, which can be converted to a UTC string by using the toUTCString method, or to an ISO string which is always in the UTC format. Note that UTC timestamps are always in milliseconds since January 1st, 1970 at midnight UTC. The visualization at the bottom shows a simple illustration of time zones and the location of UTC. Let us now go through some practical examples of date manipulation using JavaScript. The first section shows the use of date arithmetic. The addDays function takes a date and a number of days and returns a new date object with the specified number of days added. The daysBetween function calculates the number of days between two dates. The output shows the result of adding 5 days and the number of days between the two dates. The second section focuses on date validation. The isValidDate function checks if the input is a valid date object, and if the date is not a number, which would indicate that it is not a valid date. The isLeapYear function checks if a year is a leap year by following the leap year rules. Finally, the isWeekend function checks if a given date falls on a weekend. The third section presents date formatting techniques. The format date function formats a date into the format year month day, ensuring that the month and day parts are padded with zeros if they are less than 10. The getRelativeTime function calculates a relative time, such as 5 days ago, using the intl.relativeTimeFormat object. The output shows the formatted date and the relative time. Finally, the fourth section demonstrates working with time ranges. The isDateInRange function checks if a date falls within a start and end date. The getBusinessDays function calculates the number of business days between a start and end date, excluding weekends. These examples should give you a practical idea of using the JavaScript Date methods. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.